Thank you, Alexandra. For those of you who are doing the treasure hunt, I'm not gonna sing the Justin Bieber, just for. If you have the list, somewhere there is supposed to be me singing the Justin Bieber that I'm not gonna do it. And if you're looking for there's another lady, another speaker from Fortinet. We're doing the same thing at the same time. If you're looking for IoT, you should be on the other track. I'm giving you your last chance to go to the other. No, no, I'm not gonna sing Justin Bieber. Is that? No, no, no. Okay, I was here last year talking about some malware. Now I'm gonna talk about another malware, which is the ransomware. Reversing, see it has already been reversed, a polymorphic file-infecting ransomware. But first, about me, I work at Fortinet, of course. I have some articles. It's actually free to download in Virus Bulletin. And I have some of those conferences that I attend to. This one is my profile pic, but deep inside when I do the malware analysis, that's me. We're going to talk about some ransomware. No, there's another ransomware we're in. But if you're going to look at the different malware categories, we have viruses, POS, botnet, ransomware. But we're going to talk about ransomware at the same time. It is also a file infector, which is a virus and a file infector and a ransomware. Most of the time, ransomware is they just encrypt your files. And then what happens is you can just delete your files, or you can bring that files, and then if you put that files into another system, it won't infect your machine. But this one, if you're infected with ransomware with this kind, okay, if you bring that to another computer, you will help the ransomware spread because it is now a file infector. It is called actually Birlock. For Birlock, we're going to talk about the reversing stages. We're going to talk about its metamorphic algorithm, how to get the infected file. We're going to see the on-demand polymorphic algorithm. It says on-demand because it's kind that changes every time it encrypts and decrypts. Every time it uses the code, it re-encrypts it back with a different key. And then, of course, we're going to see some visible signs and unlocking features of how do we unlock the infected machine. Oh, it's not working. Okay, let's say about the basic for file infector. When we say file infector, it attaches the malware code into the host file. There are different kinds. We have the appending, prepending, cavity, maintains persistence by infecting the files. And then normally it is hard to restore because once you didn't restore it properly, it will not work. For example, your calculator.exe is infected. You were not able to restore it. It will not compute for you. Probably 1 plus 1 will become 3, something like that. And a ransomware, of course, it holds your computer for ransom, encrypts your files, and normally it uses bitcoins for payment, and of course it uses the Tor network so that you won't be able to trace the malware authors. And what is Birlock? Birlock is a combination of ransomware, a file infector, on-demand polymorphic, it has metamorphic, and of course it locks your screen. Something like that. Oh, I think we're done because I'm infected. If you're infected with Birlock, which you will see something like this because my computer is Canadian, that's why you have the flag. If you're infected, if your computer is infected with Birlock, it will show the Romanian flag, and probably the 250 CAD will change to times 3, 750 lei, right? Something like that. Yes. The good thing with some ransomware, the good thing with some malware, it is educational in some sort. For example, you don't know what is Bitcoin, it will explain what is Bitcoin, right? How to pay a fine, okay? So if you're infected with ransomware, if you're infected with a malware, it's not all that bad. You can learn something from it, like this. And not only that, if you don't know where to get the Bitcoin, it gives you some location. This actually is an actual location in Vancouver. You can go there. There's an ATM machine. You can exchange your Canadian dollar, and then they will give you a number, which is the Bitcoin. That is the ATM machine. That is actually live. Or if you don't live in Vancouver, you live somewhere in Canada, or probably if you're in Romania, they will give you a list of ATM machines. And that's it. We're done. Oh, actually, it's just a props. Just kidding. Okay, let's go now for the tools that we use for reversing. We have debugging tools. You can download OllyDebug here. And Immunity Debugger is something similar with OllyDebug, a debugger, wherein the only difference between these two is this one you can use Python programming in order for you to do the script. For OllyDebug, the old one, okay, you have to do some scripting, compile it, and then use the plugins. But for the Immunity Debugger, you can use Python to do the scripting, and that's it. It's actually easier to do immunity debugging scripting than the OllyDebug. And x64, this one is being developed. Okay, this one is good for 32-bit, and this one is also good for 64-bit debugging. So if your malware becomes 64-bit, you can just grab x64 DBG and then do the same thing. It's almost the same with these three. Okay, so that's the main tools that we use for debugging. Let's now talk about Birlock as a common malware. Okay, normally when we debug, when we do the reversing, okay, for this one, when we have the decryptor, that means this one is encrypted. All you have to do is to run the decryptor, and then once the whole thing is decrypted, you can use your IDA Pro, you can use your disassembler, you can use your any tools that you want, and then you can read the malware itself. Okay, but the only problem with Birlock is this. At first, if you see the executable file, if you are here earlier for the other talk, it discussed the MZP header. Okay, it is a very complicated one, but this one, okay, if you're going to look at the infected Birlock file, okay, you only have the text section and the resource section, and then you're going to run step 2, you run the Metamorphic algorithm to decrypt some area in the text, and for the next step, this Metamorphic algorithm just created the decoded bytes. You run the decoded bytes, you get the main function. You get the main function, you get now the OnDemand Polymorphic. Why is it called OnDemand Polymorphic? Every time it wants to, for example, this one, the boxes here are different functions. So if you want to execute this part, it will be decrypted. Once that particular code is decrypted and executed, it will be encrypted with a different key. That's why it is OnDemand Polymorphic. It will look something like this. So it will now be different from the original bytes. And then it will become this. Every time you uses the on-demand code will be changing. So if you have lots of that in this Birlock malware file, you will look like something like a Christmas tree within the code if you're trying to highlight them. And then finally, this particular area is actually your host file. The host file is the calculator, your notepad, your infected files. The trick is you get everything, you just grab this, and then now you already have a clean version of your infected file. Let's now go to the Metamorphic algorithm. This talk is actually good for 2 hours. Okay, for metamorphic algorithm, the basics is, okay, these are readable codes. Bob EAX, XOR EAX, and so on and so on. But if you're going to look closer, these codes are all the same. They only put value 0 to the register EAX. The same thing with other malware. If they're using metamorphic algorithm, they're just using different combinations of code, but they're still doing the same thing. So that is metamorphic algorithms, something like this. Normally, they are hard to find similar bytes if you're trying to do detection. Unknown length of bytes and unpredictable code, it will look something like this. This is on the second stage. Okay, it is different in sizes. It's normally less than around 28 kilobytes. I think the slides will be shared in the website, so you can just don't memorize the whole thing. For I compared sample 1 and sample 2. Sample 1 is something like this. The whole instruction, this whole block, is only doing this. It decrypts 4 bytes. Okay? The second 4 bytes is this. It executes the whole thing. It just decrypts this one from here to this one. Same thing with this. That is metamorphic. Metamorphic, if you compare that to sample 2, same thing that happens, but if you can observe, I didn't remove the frame. This frame, this one, are actually the size of the earlier version, if you notice. Okay, so this changes even the size of the codes, the mixture of the codes is different from the other sample. If you get sample 3, you will get another set of different codes. Again, they're just using this, encrypting the first 4, and this one is long. Okay, the trick is, this is sample 1, and this is sample 2. If you're going to compare sample 1, this is the 4 bytes of sample 1, this is the 4 bytes of sample 2, this is the second byte, and this is the third byte. Okay, it's a very complicated, it looks like a very complicated one, but there is a trick on how to just get the decoded bytes by. See, everything here is actually doing something like this. The only difference is this one changes. Okay, if you want to do the detection, all you have to do is to look for this one. They are the same in every infected code. How to get that one? I'll show you a video on how to get those things. It decrypted the first byte, the first 4 bytes. It decrypted the second 4 byte. Okay, it always stops on something like that. And it decrypts the whole thing. It is a very long, it is an approximate 28 kilobytes of code just to decrypt a few pieces of decoded bytes. It's around like 30 minutes. So I'll be watching that for 30 minutes. No, I'm just kidding. Don't blink on the last part because it will tell you how to get the decoded bytes without running the whole thing. Oh, now I can sing the Justin Bieber song while they're doing this. Yes. See, on the other side is actually doing the decryption, and then this one changes. The good thing with the debugger is you can actually see everything that's happening in the code. And then I fast forward, doing everything, And then at the very end of every metamorphic code, there is a call or a jump. All you have to do is to put a breakpoint on that particular call or jump, and then everything will be called after this. It will actually call the very first decoded bytes, and then from that, you can now run the malware code. See, it's the same thing. So all you have to do, if you encounter a malware that has metamorphic code, all you have to do is to look for the end, the call or the jump, and then that's it. You're done with the metamorphic code. It doesn't only applies to beer luck, it applies to every malware that uses metamorphic code. We're done with that. We're now going to look for the file, beer luck as a file infector. First, you have to know, of course, what kind of virus is the malware, and then how to extract. The main idea for the file infector is you have to know where to get the host file, okay? Some kinds of file infectors, appending, prepending, and so on and so forth, something like this. This, something like a squid or octopus, is the malware. Appending, it just added the malware. Prepending on top, cavity, it puts on the free spaces on the code, and then overwriting, it totally destroys your infected file. There's no way to clean that. And then companion, all you have to do is to delete this, and then keep the host.exe. For beer luck, it's not somewhere on the normal categories. For beer luck, it gets the whole encrypted host and put it on the malware code. Okay, so that is how it infects. All you have to do is to look for that, and then now you have the solution. To extract the host file from the file, okay, we are going to have this something like this. This particular part is the host file. You have to look for this code. That is the key. And that is the location of the decryption key. We're going to do the XOR. This is actually the simple encryption. You have to look for that for the code if you want to decrypt the malware. And then the next D word is the EBX. And then this particular area here is actually the actual decryption. If you're using Immunity Debugger, all you have to do is to do a script, Python script, wherein you have to imitate this code, and then you're done with the decryption. It will look something like this once it is decrypted. So this particular bytes encrypted, after running this, you will see the name of the infected file, the MZ header, the PE. That means you already have the decrypted code. That is how you extract the host file from beer luck infection. That's the original host name. Question? Am I too fast? There's still more. Okay, for beer luck as a polymorphic malware. Okay, you've seen earlier on this stage, it is encrypting or decrypting the first block of code, and then it encrypts back, and then you will see something like this. Okay, if you see this orange part is actually, this is the decryption routine. The next one is the encryption routine. Decryption, encryption is always like a sandwich. Okay, decryption, encryption. In the middle, that is actually the actual code being executed. You can actually click this. So that is the metamorphic part. And this is what we call, look at this, the call 40136C, and this is the 4012AB. After executing this, that means this is already decrypted. After executing this, it will call again the same function, but this time it is using a different key. That is what we call the OnDemand Polymorphic. So another time it executes, it will get another key. Going back, You can see this. It is all of them are on the slides. Should be able to see them. See? It's not just very clear, but it should be clear on the slides that I gave. Something like that. That's the code. How does it work? First, it uses the decryptor to decrypt the block of code. Something like this. It uses some garbage code. It has some insanity check, XOR to generate the key, and XOR another XOR to decrypt. You will look something like this. The red ones, they're actually garbage code. That means it is just for you to get confused when you're doing the debugging. Okay, but the actual code is this one. Okay, it calls the key, which is this, starting location of the key bytes. It generates the number of bytes to generate. The actual key generator, it generates the key. And this is the actual decryption, that particular call. And then the starting of the call is this one, the XOR D word. It is a simple XOR encryption, decryption, but because of this technology, this idea of putting some garbage code in between, it makes it a very complicated sample, very complicated malware. Okay, after the decryptor, it executes the newly decrypted code. It uses the RDTSC function, the read timestamp counter. That is what gives you the key, the new key. Every time it generates the new key, it uses this function. And then afterwards, again, it uses the new key generator to generate the new key. Okay, same idea, RDTSC, it saves it in different memory location, and then XOR, and then produce the decryptor. See, this is now the decryption part. Starting location, I think it's similar to the encryption, but this one is similar to the decryption earlier, but this one is the one that generates the new key, this particular part, and then it calls the encryptor. Okay, if you're going to look at this one, this is the original key. Okay, after running this, it will become a different key. See the difference? Okay, this is the one that generates, this is the call for the RDTSC, and then this one is the new key. And then that's it. It's encryptor. Now it's encrypting the key, or encrypting the block of code using the new key. Or a more visual representation is something like this. Okay, this is the original bytes, encrypted with the old key. Okay, the first line, I just got the first line, put it here. After decrypting, it will look something like this. This is now actually a call or a jump, something, and then this is a readable code. After executing that, the new key will be a different one. Okay, this is now encrypted with the new key. Okay, it is totally different from the very first one, but they are the same set of codes. Okay, this one is encrypted with old key. This one is encrypted with the new key. But all you have to do is to get this one if you want to do the detection. If you want to do the detection, even though you have different samples of beer lock, all you have to do is to get the decrypted key, and then you can now detect all version, all samples infected by the same version. If you're going to look at the detection for the code, all you have to do is to do not get detection from this. All you have to do is to get detection from this code if you're doing the antivirus detection. And we're back as the ransomware, so you have to click and so on and so forth. And now, we're back to the BeerLock as ransomware. Okay, you have seen actually the visible signs earlier. Once you've seen this and this, that means you're already infected. If you're already infected, it's either you pay, if you're rich. If you're not rich, I don't have any solution for that. If you're not rich, the good thing with Berlac is you can actually, the problem with this one is once you're infected, it locks your screen. That means you cannot do anything. You can only browse from different tabs, but it is already locked. Okay, I'm going to show you a video in order to unlock. It is actually very easy unless they already updated the new variant, but this sample is easy to unlock. So this one, the same thing, the same screens. Okay, the thing with the cleaning is it's either you manually create solution to the clean infected files, download reliable standalone solution. You can probably grab it somewhere in the internet. Okay, always make sure that your AB and security applications are updated, and Porty client is free. You can download that and then install. That's the marketing side. The problem is, what if your system is already locked, right? You can do the earlier version of the steps, but what if it's already locked, okay? You can reboot the system into safe mode, remove the malware entry on the startup registry, then go back to this stage, okay? How do we do that? I think that's the part where I'll show this. This one is real time. That means I run the malware on that one. It will take you, see, I'm infected. Real time. Real time is starting the machine. And then, if you're infected, you can restart the machine. I put some clock so that you know that it's real time, how long it will take for it to show that you are still infected. It will look like that you're not, but after 15 minutes, no, not 15 seconds, it will show you again the screen because it is trying to warm up, okay? You restart, you're infected, you restart, and then, oops, you're not actually infected, right? 29 seconds, oh, you're still fine. You can do something else. 30 days, oh no, 35 seconds, 37 seconds. Come on. It's real time. We cannot pass forward. Oh, 52 seconds, it will show the screen. And then again, you restart, but this time, try to choose the safe mode. And then, if you're in safe mode, it will not run the auto start function or features. Okay, all you have to do is to run regedit. If you know how to use the regedit, okay, look for it. You can actually search for run. This technique also works for other malware, not only for Berlac. It's just a tip. Okay, you search for run, and if you see something like you don't understand what's the executable file, even if it is not Berlac, just delete. Delete, right? The problem with Berlac, it has two. Just to make sure that you deleted the first one, just to make sure that you clean everything, you keep clicking run, searching for run. See, there's another one. Again, delete. If you don't know of course, if you says calculator, don't delete. But if it's on run, it's suspicious, right? Just delete. And then I will restart again, real time. Earlier, it shows you after 40, is that how many seconds that? 42 seconds, 52 seconds, it shows you again the screen. And because we removed the auto start, the run features, auto run features, it should show that it should exceed the 52 seconds. There should be no more screen display, right? I ran it for like 5 minutes. So just to make sure that you're not infected. Real time, we cannot pass forward, right? No, we cannot pass forward. Oh, 51, 52, right? We didn't see the lock screen, but you're still infected, remember? We just removed the lock screen. What are we going to do? It is not showing. You can now go to the eradication stage wherein it's either you download the clean solution, you clean it yourself, and so on and so forth. But still, if you don't see the screen, you are still infected. Remember that. See, 1 minute, 26 seconds. I will pass forward. I think it shows. No, just kidding. It's not doing anymore. Come on, stop. Oh, I actually finished by 30 minutes. Okay, to wrap up, okay, for reversing, if you want to play with beer lock or any malware, all you have to do is if you find a metamorphic malware or beer lock, just look for the call or the jump. EAX, EDX, probably sa different registers every given time. Okay, set a breakpoint, it will end the metamorphic algorithm. Okay, and then of course, just copy the decrypted code from memory if you want to analyze it using IDA, OLE debug, and so on and so forth. For detection, you're going to use just look for the decrypted code. Do not get the still encrypted version. For cleaning, you can remove the entries that, like what I shown you earlier, remove the entries from the registry keys, and then after that, you can extract the host file. And I think that's the end. Any question? Question? No? The question is if the malware is specific, if the algorithm is specific to this beer lock. Okay, every version of beer lock that I've encountered, they still have the metamorphic, they still have the OnDemand Polymorphic. The only difference is they just change the size, the length, but still the technique is still there. But I haven't seen the new version of beer lock wherein probably they can trick the reg edit or something. But so far, it will still work. So it's not variant specific. If you encounter beer lock, it still work, this algorithm.
Okay. Just one other question. How can you decrypt if you have, let's say, the same debugger tools infected?
Oh, you mean if your debugger is infected?
Yeah.
If your debugger is infected, just get another machine and then debug it on the other machine. Try to use when you do my work as a researcher, you run the malware in an environment, like for example, you have your own VirtualBox setup or VMware setup. You run your malware there and then grab it, then you can debug it to another copy of the malware. Or you can do it right there and then. You can just debug at the same time, do the infection. Or you can just resign or something if you cannot. No, just kidding. Other question?
Here. I'm wondering whether you have encountered any other source of randomness than the read timestamp counter.
You mean if there's some other way it creates random key?
Right, because the way I understood it so far is that the malware gets its randomness to decrypt to random bytes from the read timestamp counter. And
using the RDTSC, right?
Right.
For this, for Birlock, it's just using the RDTST, but generally for any malware in general, it can use the get tick count API. It can use actually some of your information, your MAC address, your IP address. It can use that to generate some key added to, you can actually combine anything. And then you can have, one person will have a different set of keys because he has a different MAC address, and then another person will have a different set of keys, so set of infection because it has a different set of information. Yeah, but for this one, it only uses the RDTSC. Question? I give $1 for. If you have no more question, how do you say it? Multimask. Thank you.